Hello everyone. So now today we will solve the questions of theory of computation that has been asked in the GATE 2022 exam. So the first question is, which one of the following irregular expressions correctly represents the language of the finite automata given below? So this is the automata given below. Okay. So you have to write the regular expression for this. So we will take few ways that how can we write the regular expression. So first, the basic way is just check the smallest string that will be accepted by this automata. So if you will see, the smallest string is small a. If you see properly, the smallest string is small a and small b, because you can see from a it is going to the final state. From b for it is going to the final state. So a and b are the smallest strings, right? So check from the given options that which of the regular expression are generating this a and b. Okay, there is a basic mistake in this option. Here there is asterisk. There is also asterisk here and also here. Okay, so if you check this first option in the a part, so from the A part, you can see the A and B cannot be generated because the smallest is ABA or BAB. So from the A part, A or B cannot be generated. Let us go to the second B option. So in the B option, yes, A or B can be generated. So A can't be option. B can be. Let us see the C option. In the C option, the smallest is AB or BA. So here also A or B cannot be generated. Let's see the last option. In the last option, A or B can be generated because the first part can be epsilon. So in the second part, in this, A or B can be generated. Okay. So the options can be either B or D will be the correct answer. Okay. So you can see that by taking the smallest string, only the two options have been eliminated. Okay. Now we will try to write the regular expression. So now how we will write? First see each component. Like for this component, it is A, B star and B, and we are coming to the original state. Like A, B star, B. You can see on A it is going to here, B star on it is on here only, and on B it is coming to back. So it is A, B star, B, it is coming to back, right? Plus on B, A star, A also it is coming back. On B, A star, A. In both the cases, it is coming back to the original state, right? Now, from the original state, if it has go to the final state again, so one way is A, B star, and the other way is B, A star. So this cycle, suppose it has came here and then here, again here and then here. This is a cycle, or here, here, and then here and here. So there can be many cycles. So here you can have to write asterisk. There can be any number of cycles. Now after these cycles, it has to reach the final state. So it can reach through A, B star or B, A star. Okay. So this will be the final regular expression for the given automata. If you see the option D is correct. Okay, the option D is correct. So you can see that suppose if you very less time is remaining in the gate exam, and if you are not able to write properly, just take the smallest string and try to check the options. Sometimes the three options gets eliminated, but here only two options eliminated. So you have to try to write the expression. Okay, so we have seen both the ways, how to apply the short trick and how to actually write the regular expression for the given automata. Okay, so now we will move to the second question that has been asked in the GATE 2022 exam. So this is a question of 1 mark. In the question it has been mentioned that which of the following statements is are true. Always focus on this keyword, that what has been asked, whether true or false. Okay, so in this question the statements which are true has been asked. Now the first option is, we'll go option by option. First option is every subset of a recursively enumerable language is recursive. So now first we have to understand what is recursively enumerable language and what is recursive language. Okay. So what is recursively enumerable language? It means that a language is given and you can make a Turing machine for that language. And suppose if a string belongs to that language, then definitely the Turing machine will halt. But if a string doesn't belong to that language, then the Turing machine can halt or can go into the loop. Then that language is recursively enumerable language. And now what is recursive language? A language for which you can draw a Turing machine, okay? And the Turing machine will definitely halt whether the string accepted by that language or not. It doesn't matter. That Turing machine will definitely halt in both the case, whether the string is belongs to that language or doesn't belong to that language. So that language will be recursive. And if the string is accepted by the language and if the Turing machine halt, but if the string doesn't accepted by the language, the Turing machine can go into the loop or can halt. So in that case, the language is recursively enumerable language. So it is saying that every subset of recursively enumerable language is recursive. Now suppose the language is sigma star. Sigma can be anything, A, B, C, anything, or zero, anything. Sigma can be anything. And the language is sigma star. It is a complete language. And every other language will be subset of this. Right? We know that L equal to sigma star is recursively enumerable language. Right? R will be recursively enumerable language. But there all the languages are subset of this language. So obviously there are some languages which are not recursive. So suppose whenever if we take any language L1, which is possibly that it is not recursive, which is not recursive, and that language will obviously be subset of this language, because you can see this is the complete language, it is recursively enumerable, but any language which is not recursive will be subset of this. So that's why this statement is false. Okay. Now the second statement is, if a language L and its complement L complement are both recursively enumerable, then L must be recursive. So now I have explained what is recursively enumerable language. Recursively enumerable language means the Turing machine will definitely halt when the string will be accepted by the language. Okay, but Turing machine may or may not halt for those strings which does not belong to that language. Okay, but it is saying that a language L is recursively enumerable, means the strings which belong to L, the Turing machine will halt. And it is saying the L complement is also recursively enumerable, means the strings which does not belong to L will also be L complement, means in L complement those strings will come which does not belong to L, right? And it is saying L complement is also recursively enumerable, means whatever the strings belong to L complement, on that case also the Turing machine will halt. So Turing machine is halting for both the cases, whether the strings belong to the language or string doesn't belong to the language. So this is the meaning of the actually the recursive language. So that's why the L will be recursive. Recursive means the string recursive means the Turing machine will halt for all the strings. So that's why the L will be recursive. This is the correct option. Now the option C is complement of a context-free language must be recursive. Okay. We know that the complement of a context-free language may be context-free language or may not be. Right. But we know that the complement of context-free language is CSL, context sensitive language. Okay. And we know that all context sensitive languages, all context sensitive languages are recursive languages. So the complement of CFL is CSL, and all CSL are recursive. It means the complement of context free language will be recursive. So that's why this option will be also correct. Now the last option is if L1 and L2 are regular, then L1 intersection L2 must be deterministic context free. We know that the intersection of two regular languages will always be regular. So L1 intersection L2 is regular. Now we know that regular languages are subset of deterministic context free languages. So regular languages are the subset of deterministic context free language. Means every language which is regular, it is by default deterministic context free language. So we know that L1 intersection L2 is regular language. Why? Because L1 and L2 are regular and intersection of regular language is regular. So L1 intersection L2 is regular. So all regular languages are deterministic context free language. So L1 intersection L2 will also be deterministic context free language. So that's why this option is also correct. Okay. So option B, C and D. These three options are correct and A option is false. Okay. So now we will move to the next question that has been asked in the GATE 2022. This question is of 2 marks, right? Now it has been asked in this question that which of the following is are undecidable. So the first option is given two Turing machines M1 and M2, decide if L of M1 is equal to L of M2. Now, first we have to understand what is decidability and what is undecidability. So, you know that, for example, all recursive languages are decidable. Means the Turing machine will definitely hold. All the recursively enumerable languages are partially decidable. Why? Because the Turing machine will definitely hold for those strings which belong to that language. Right? So all recursively enumerable languages are partially decidable. Recursive languages are decidable, and the languages are which are not recursively enumerable will be undecidable. Now, if you see, the first language is a very standard problem, which is the equivalence of two languages. So the equivalence of two languages, this problem, which is equivalence of two languages, is undecidable. So this is correct. This is undecidable. Okay, because if two languages same, it means whatever input we will give, the output for both the languages should be same. Okay, if we give the same input to both the languages, the output should be same. So we don't know that because we have to test for all the input languages, and it is not possible because we don't know when we have to stop, right? So it is undecidable. Now second part, given a Turing machine M, decide if the language is regular. So this is also very standard problem, the regularity, to check the regularity of a language. So it is also undecidable. It is also undecidable. Now the third is given a Turing machine M, decide if M accepts all strings. So it is a completeness problem that L equals to sigma star, right? It is saying that you have to check that if there is a language L and you have designed a machine, Turing machine for that, which is M, so whether M is accepting all strings or not. So whether this language is sigma star or not. So if you want to check that whether the language is sigma star or not, you have to check for all the strings, and the number of strings will be infinite. So you don't know when to stop. So that's why this is also undecidable. Now the last option, given a Turing machine M, decide if M takes more than 1073 steps on every string. So what you have to do, you have to just count the steps that the Turing machine is taking on moving left or right. Okay. So you have to just count maximum up to 1073 plus 1. You have to count maximum up to 1074 steps. And after that, you can tell that whether the Turing machine is taking suppose you have to give a string. Okay. So on a string, you can check that whether the Turing machine is taking this much steps or not. Okay. So suppose it is saying that if M takes more than 1073 steps on every string. Okay. So if on any string, if it takes less than 1073 steps, means up to 1073 steps, at that moment you have to just stop. So it means it is decidable, because we know that when we can stop. We know that if we get a string, on which the Turing machine is taking less number of steps, means less than 173 or equal to less than or equal to 1073 steps, then we can say that the Turing machine is not taking more than 1073 steps on every string. So we know that when to stop, we have a terminating condition. So this language is decidable. So we can say, see here that options A, B and C are undecidable and the option D is decidable. Okay. So in the question has been asked that which of the following is are undecidable. So which are undecidable? A, B and C. Okay. Now we will move to the next question. So now in this question, two languages are given, L1 and L2. Okay. So we have to see both the languages. First we'll see L1. What is L1? In the L1 it has been mentioned that A ki power n, W A ki power n, right? But here it has been mentioned that the W belongs to A comma B whole star. But if you see here, there is no condition on n. So whenever there is no condition given, by default we take it as n greater than equals to 0. Now if you see that, if we take n as 0, then L1 will become equals to W. If we take n equals to 0, if n equals to 0, so L1 equals to W. So it means W is belongs to A comma B ka whole star. So it will be equals to A plus B ka whole star. So if you can see that all the strings will belong to L1. If you will take n equal to 1, then some strings will also come, which will be subset of this. So overall, the regular expression for L1 will become A plus B of whole star. So you can see that this is regular language. Okay, so L1 is regular language. Now you have to see for L2. The L2 is XW, WXWR. WR is the reversal of W. So for example, the W is A double B, right? And in the mid there is X and then WR means BBA. So X is, well, if you can see, X belongs to A comma B ka whole star. So it means X also is a combination of A and B. So up to from this part to this part, X will also be a combination of A and B. So suppose this is a complete string of A and B. So you can take this complete part in X only. And only the thing is that the first character and last character to be same. So the regular expression for L2 will be A, that here also given that the length of W and X should be greater than 0. So here you will use plus. Plus means that at least the length should be 1. So this is the regular expression that they end with the same symbol. So this will be the regular expression for L2. So both L1 and L2 are regular. In the options, two languages have been asked. One is context free and one is regular. Do you know that these are the regular languages? And we know that all the regular languages are context free languages. Okay, so if a language is regular, it will definitely be context free language. So both L1 and L2 are regular, and because they are regular, so they will also be context free language. Okay, so now let us see the options. In the question it has been asked there, which of the following is that true? Always focus on this keyword. L1 and L2 are regular, correct? L1 and L2 are context free. This will also be correct because L1 and L2 are regular, and all regular are languages are context free languages. So this will be also correct. Option C, L1 is regular and L2 is context free. Correct. L1 is regular and L2 is also regular, so it is also context free. So option C is also correct. L1 and L2 are context free. It is correct, but not regular. This is wrong. L1 and L2 are context free but also regular. But here it is given that it is not regular. So this option is wrong. So the correct options are A, B, and C. Okay. So this question was of 2 marks. So you can see you can easily solve the questions of the GATE exam, right? Now see, this is the last question in TOC that has been asked in GATE 2022. Now here 3 languages have been given and different statements are given. Okay. So we will see each statement. The first statement is L1 is non-context free, but L2 and L3 are deterministic context free. Here you focus here on the keyword. What the keyword is saying, which of the following statements is are false. So we have to calculate the basis of which are the false statements. Now first L1. L1 is LWW. This is a very standard problem. Okay, many times it has been asked in the GATE exam, and we know that it is not, L1 is not context free language. And there is also one standard problem regarding that L1 complement. The complement of this language is context free language. Okay, the complement of this language is context free language. Okay, so first is L1 is not context free, correct, but L2 and L3 are deterministic context free. So if you see L2 is, you have to compare A and B only. So to compare, you have to compare only between A and B. It can be done with the help of one stack. So L2 is deterministic context free language, correct. In L3, you have to compare B and C, number of B's and number of C's. So it can also be done using deterministic context free. So it is L2 and L3 both are deterministic context free. So L1 is not context free, but L2 and L3 are deterministic context free. So this statement is correct. L1 is correct statement. But here you have to tell about the false statements, right? Now the second statement, neither L1 nor L2 is context free. This is wrong because L1 is not context free, but L2 is context free language. Okay? So option B is false. So now this option will be correct according to this question because this option is false. The third option is L2, L3 and L2 intersection L3 all are context free. So we know that L2 and L3 are context free. We have to check for L2 intersection L3. Okay. So try to write. You can see in L2 number of A and number of B is same, and in L3 number of B equal to number of C. So in the intersection, L2 is saying that number of A should be equal to number of B, and L3 is saying that number of B should be equal to number of C. So what does that mean in the intersection? That number of A should be equal to number of B equal to number of C. So L2 intersection L3 means A ki power n, B ki power n, C ki power n, such that n should be greater than equal to 0. Okay, this is L2 intersection L3, and this is not context free language. So here it has been mentioned that L2 intersection L3 is also context free. So this option is false. So that's why it will be correct, because in the question the false statements have been asked. Now the last part, neither L1 nor its complement is context free. So I have told that yes, L1 is not context free language, but its complement is context free language. WW complement is context free language. In the question, it has, in the option it has been mentioned that neither L1 nor its complement is context free. This is wrong. L1 is not context free language, but its complement is context free language. Okay. So this option is wrong. So that's why this will also be correct. So correct options are B, C, and D. Okay. So we have seen all the questions of theory of computation of GATE 2022. Okay.